So I'll start by looking at a basic bit of Python code, a function containing an if statement, a while loop and an else part. So this is Python code if you're not familiar with Python. So we've got a definition of a function here. The function is being called. The function doesn't have any arguments. The function executes an if statement with an else part and a while loop. It contains some integer values. It contains the Boolean literal values, false and true. And it also assigns some variables. So Python does not have variable declarations or variable definitions. Variables come into existence the first time they're assigned. So when we call this function f, we come in at the top of the function. The if statement goes into the first branch because true is true. The variable a is assigned to 0, and what that will do is to bring a new variable into existence called a, and it will bind that variable to a Python object, and that object will represent a Python integer. So that's what variable assignments always do in Python. Variable assignments bring variables into existence, and the variable is then bound to a Python object. Python is an object-oriented programming language, and all Python values, functions and classes are Python objects, and variables then bind to Python objects. So the control structures in Python are pretty obvious. We've got if statements, while loops and so on, and Python uses indentation to determine the structure of the code, which is really, really important. And the first coding guideline I'm going to give you is always use 4 spaces for indentation. Never use any other number of spaces, never use tabs, always 4 spaces. Why? Well, it makes sure that your code is consistent, everybody can read it, and you don't trip up when you move to a different text editor. So although people are often tempted to hit the tab key, be very careful you end up with 4 spaces and not tabs in your Python code. Otherwise you can get real surprises when you go to a different text editor. The Python language actually merely requires that within a control construct the indentation is consistent. However, the code on the right hand side is pretty unreadable and people are going to hate you for writing it. So do always consistently use 4 spaces for each level of indent in all of your Python code. Then Python distinguishes between assignment and the equality operator in the same way as C. So the assignment operator is a single equals sign, the equality operator is 2 equals signs. So here we're assigning a variable a to have the value 2 and immediately testing if a is equal to 2, which it is. So we'll go ahead and assign b and set b equal to 4. So it's a good Python coding guideline to include breathing space around operators as shown here. Don't miss spaces out between operators. So a equals 2 with no spaces or 2 plus 2 with no spaces is frowned upon as a coding guideline. It's legal but usually seen as better coding style to include breathing space around all the operators. So here's a Python example that introduces some other very common Python features, the list and the dictionary. Here we have a Python function that takes 3 arguments, and it uses those arguments to assemble a Python dictionary. The arguments are actually selected by subscripting a Python list. So a list in Python is a data structure that consists of a set of values separated by commas and enclosed in square brackets. So here we're bringing a new variable x into existence by assigning that variable to a Python object consisting of a list of 3 values. We then subscript that list using the subscript operator, which has a very similar meaning to the subscript operator in C. So we start indexing from 0. So x0 is the first value in the list, or 4, x1 is 5, x2 is 6. So we're passing the 3 values 5, 4, 6 into our function, where they're bound to the 3 variables a, b and c, a, b and c being arguments to the function, which are effectively local variables inside the function. We're then using those 3 values to build a dictionary. So a dictionary in Python is a set of key value pairs. So the keys in this case are the integers 1, 2, 3, and the values are the values of the variables A, B and C. So here we've got a Python dictionary with 3 key value pairs. And that entire dictionary forms an object which is returned as the value of the function. So we're calling the function with 3 integers picked out of this list, and the function is being returned with a complete dictionary. When we evaluate the function, that will be the value that was printed out. So you can see here the final value of the dictionary. In terms of layout, it's usually regarded as good practice in Python programming to put a space after each comma in a list and after each colon in a dictionary. And that applies when we're defining the list, when we're defining the arguments to a function, when we're defining a dictionary, and when we're passing arguments into a function. So in each case, you'll see a single space after each comma or colon, generally regarded as good coding style. So here's 2 examples of parenthesized language constructs involving brackets of some kind, a regular expression at the top and a dictionary at the bottom. And here we've got a dictionary whose keys are actually strings in this case. So the 4 basic Python data types are the Boolean, integers, strings and floating point values that we'll meet later. And strings in Python, it turns out you can write either in single quotes or in double quotes. The values of the dictionary, well in this case we've got a mixture of integers and lists. So in general in Python you can nest anything within anything. You can nest lists, within dictionaries, within lists ad infinitum. And in terms of a coding guideline, it's generally recommended not to put extra spaces within parentheses. So no extra spaces within the parentheses of this expression, no extra spaces immediately inside the outer parentheses of the dictionary or the list. That's what's generally recommended. Functions can have any number of arguments, and it can be very useful to give function arguments default values, as we've got here. So this function's got 3 arguments, argument 1, argument 2, argument 3. It adds those 3 values together, interpreting them as numeric values, and returns a single object as the value of the function. Then when we call the function, we're passing in the value of the first argument, arg1, as a positional argument, and then we're passing in the value of arg3 as a keyword argument. So you can use either the position of the argument or the name of the argument when you pass the argument into the function. And this is where having default values can be really useful. Now, in terms of the coding layout, it's usually recommended to not include breathing space around the equal sign where it appears in defining the default value of the argument, or where it appears in specifying the values for keyword arguments. So with default values and keyword arguments, it's usually regarded as cleaner and easier to understand to actually bind the value very tightly to the argument name in either case. So this is an exception to the rule of breathing space. Don't put breathing space around default values and keyword argument values. There's quite a bit of flexibility when it comes to making assignments. One thing you can do is to write a so-called expression list on the left-hand side of a variable assignment. So here we're assigning 5 variables in one line, which is neat. And on the right-hand side, we need to provide a list of 5 values. And of course, you could write out a list of 5 values, but suppose we want to set all the values to the same. Well, what we could do then is to take a list of a single value and then repeat it a given number of times. So on the right-hand side here, we've got a list consisting of a single value, or 1, and then we've repeated that 5 times to make a list of 5 values. So this is a neat shortcut for setting all of the values A, B, C, X and Y, each to the value 1. And notice in terms of spacing, we've written a space after each comma, no space inside the square brackets of the list, and some breathing space around the multiply operator. You can also chain assignments in Python, just as you can in C, although Python doesn't allow side effects in assignments. So there's no plus plus operator in Python like there is in C. But you can chain assignments this way, and notice the breathing space around the equals operator. When you put multiple operations in an expression, it's often recommended to take advantage of spacing in order to clarify the operator precedence. So in Python, as in all programming languages pretty much, multiply has a higher precedence than plus, and so it's often recommended in Python coding guidelines to miss out the breathing space around the higher precedence operators, which arguably can make this expression a little easier to understand. So using spacing to reflect operator priority is often approved of in Python coding guidelines. Another simple and very common coding guideline is to write one statement per line. So here on the first line we bring a new variable into existence and bind it to an object whose value is integer 1. Then on the next line we have another object, integer 2, add it to the object integer 1 to return a third object that variable b gets bound to, and those two statements should be written on separate lines in Python. Python does, however, permit you to use semicolons to write multiple statements on the same line, but don't do it. Keep it simple and write one statement per line. And on a similar vein, Python does have a general line continuation character. So the / character can be used anywhere in Python to continue on to the next line. But it turns out you hardly ever have to use it, because there's a very useful trick, which is within inside any kind of parenthesis in Python, you can always include line breaks without an explicit continuation character. So the Python interpreter keeps track of the fact that we've opened parenthesis and then just allows line breaks at any natural position. So that means you hardly ever need to use the explicit line continuation character. Another thing that you can do, but very rarely should, is to write short statements on the first line of a function definition or the first line of an if statement. So Python allows you to write function calls or variable assignments immediately after the colon in a function or any of the control flow constructs. But again, don't do it. You're very strongly recommended in almost all of the Python coding guidelines to write one statement per line and actually separate out every control statement onto a separate line rather than taking this shortcut of multiple statements per line.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of John's webinar, Python Coding Guidelines and Idioms, whenever you want by heading over to our website www.doulos.com/od and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.